Assalamu alaikum and welcome to the Mathcast with Faria Yusuf. And in this video, we shall be doing graphs of cosine function. And to sketch the graphs of cosine function, again, the thing that we should be knowing are the values on the coordinate axes. So we know that coordinate axes are represented by 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, where our cosine of 0 is a 1, cosine of 90 is a 0, cosine of 180 is a negative 1, cos of 270 is a 0, and cos of 360 degrees is also equal to a 1 here. So with this, we can see that the minimum value for the cosine function is a negative 1 and the maximum has to be a 1. So cos of x, it ranges from negative 1 till 1. So let's sketch the graph of y equals cos of x for 0 degrees lesser or equal to x lesser or equal to 360 degrees. So for cos of x graphs, what we can see here is that on the axes, on the x-axis, I should be having 0, 90, 180, 270 and 360 degrees. This is my x-axis and I have the y-axis here. So I'm just going to sketch or locate the y values for all the coordinate axes. Cos of 0 is a 1. So this is the point located for cos of 0. Cos of 90 is a 0, so this is the point located for cos of 90. Cos of 180 is a minus 1. Cos of 270 is a 0, and then cos of 360 degrees is equal to a 1. So first I located all the points for the coordinate axes or the angle values on the axes. After that, I just have to midjoin the points making a curve, and this is how the curve goes, and this is going to be the graph of y equals cos of x. So basically y equals cos of x graph resembles the quadratic graph with minimum stationary point. So this is how this graph needs to be done. So generally what we have here is y equals cos of x, and in this image I have the graph from negative 360 degrees up till 720 degrees here. So what I have noticed here is that the graph for 0 till 360 degrees is actually the quadratic curve that I can see here, starting from here up till 360 degrees. And after that, for the second rotation, cos 2x, second rotation, I can see that it's the same graph, it gets rotated again. And on the negative axis, meaning in the clockwise direction where all the angles are negative, I can see that it's starting from negative 360 degrees and up till 0 degrees. So basically it's the same cycle which is from 0 till 360 degrees in the anti-clockwise direction. So cos of x, cos of negative x here, negative x clockwise rotation, is actually equal to cos of x, meaning all the angle values in the anti-clockwise rotation here. So with respect to this, I can simply say that cos of minus x will be equal to cos of x. And then in the second quadrant, cos of 180 minus x equals negative cos of x. So second quadrant, starting from 90 degrees up till 180 degrees, I can see all the y values are negative. It's just that the positive values, they are just having the negative sign. Therefore, in the second quadrant, cos of 180 minus x will be equal to negative cos of x from 180 degrees till 270 degrees. The third quadrant, it's cos of 180 plus x, and I can again see that all the cosine values here, all the y values for the function here, they are negative. Therefore, it's just that cos of 180 plus x shall be equal to negative cos of x. And in the fourth quadrant, from 270 to 360 degrees, y values are all positive, equal to what we have in 0 to 90 degrees. Therefore, I can say that cos of 360 minus x equals cos of x here. So these are the things that we have again deduced for the cosine function for all the four quadrants here. Next thing, cos of 360 plus x, I can see it's the same cycle that is getting rotated. Therefore, cos of 360 plus x give us the same cosine values, which equals cos of x. So these are few of the deductions that we should know about the cos of x graph here. So let's do a question. Sketch the graph of y equals 2 cos of x minus 1. So y equals, we have to sketch the graph of y equals 2 cos of x and a negative 1. So what we know about these values here is that 2 here needs to be the stretch parallel to the y-axis, and the factor here is going to be 2. The stretch factor here is going to be a 2. And about negative 1, the negative 1, it's a vertical translation downward because the sign here is a negative, and this is how we give the vertical translation as 0 and negative 1. So to sketch the graph very quickly, what other things that I know here is that this negative 1 is actually the mid-axis also. This negative 1, it's also the mid-axis of the graph, and this 2 is also the amplitude of the graph. Amplitude of the graph. So these are the 2 points that we should be knowing for the values that we have in this equation. So mid-axis is negative 1 and the amplitude is a positive 2. So to get the maximum and the minimum values on the graph, I can say that the maximum value on the graph on the y-axis has to be equal to from the mid-axis and then the amplitude. So then this should be equal to a positive 1. And the minimum value on the y-axis, that should be equal to negative 1 and then a negative 2, giving us a negative 3. So we can say that the range of the graph is actually the domain here. We know that the domain is given. It is 0 degrees lesser or equal to x, which is lesser or equal to 360 degrees. And the range of the graph, the y values, the range of the graph, they have to be from negative 3 lesser or equal to y, or cos of 2x minus 1, which should be lesser or equal to 1. So this is going to be the range of the graph here. So this is these are the few things that students should know before even sketching the graph here. So the mid-axis and the maximum and the minimum value, that they are going to be of great help to sketch the graph. How? Let's see that. So I have sketched the x-axis here representing 0, 90 degrees, 180 degrees, 270 degrees and 360 degrees. And also I have located the minimum value, the mid value, which was a negative 1. Mid value, we know that the mid value here, or the mid axis here, it's a negative 1. And then with respect to that we got the maximum and the minimum values on the y-axis. So we have the mid axis here and we have the maximum point as a 1 and minimum as a negative 3. So with respect to the mid axis, let's draw a dotted line for the mid axis here. We have maximum value, which is a 1. So when my cosine function is a 0, then I should know that the maximum value that I should be having here for y equals the equation that I had, it said it's y equals 2 cos of x and a minus 1. Therefore, if my x value here is a 0, what I can say is that when x is a 0, y equals 2 into cos of 0, which gives me a 1 and a negative 1, and my answer is a 1 here. So on the x-axis, on the y-axis, when my x is a 0, this y value for y equals 2 cos of x minus 1 needs to be a 1. The same has to be for 360 degrees because 0 and 360 degrees, they represent the same values for y. Now let's check for 90 degrees. So when x equals 90 degrees, what I know is that cos of 90 equals a 0. So if cos of 90 equals a 0, this becomes 2 times 0, negative 1, and my answer will be a negative 1. Meaning on the at 90 degrees, the y function, the y value here is going to be a negative 1. Same is going to be for 270 degrees, because for x equals 270 degrees also, the cos of 270 degrees is a 0 and the y value will be a negative 1. Cos of 180 degrees. So if I do the working for cos of 180 degrees, then my y value should be cos of 200 and cos of 180 is a negative 1, and then I have a negative 1. So y value here represents a negative 2 and a negative 1, which gives me a negative 3. So this is how I will be locating the points on the graph. And what I have seen here is that from the mid-axis up till 1, the amplitude is 2 units. I can see it's a 2 unit. On both the sides of the mid-axis, I can see the amplitude here, which is a 2 unit. So this is a quick way of sketching the graph. Now the only thing that I need to do is to join the points, and they should be representing the curve. Therefore, this is how this graph of y equals 2 cos of x minus 1 shall be plotted. So this is how the graph of y equals 2 cos of x minus 1 gets plotted. Let's do another example. Next question is from October-November 2018, paper 1, variant 2, and this is question number 4 in the paper. And the question says functions f and g are defined by f of x equals 2 minus 3 cos of x for 0 lesser or equal to x lesser or equal to 2 pi. And there is another function given, which is g of x, which is equals to 1 by 2x for 0 lesser or equal to x lesser or equal to 2 pi. Part 1 of the question says solve the equation f of gx equals 1. So here we are solving trigonometric functions. We are solving trigonometric functions. And in these trigonometric functions, they are asking for the composite function also. So this topic can be related to the functions topic, to the functions chapter, and let's see and refresh how we are going to solve for f of gx, which is equals to 1. So solving part 1, it says f of gx, and this should be equal to 1. So the composite function f of gx means that within the function f, in place of x values, I should be substituting g. So function f is 2 minus 3 cos of x, and in place of x, I shall be substituting the function g, which is x by 2, and this then shall be equal to a 1. And solving it further, I can say it's 2 minus 1, which is equals to 3 cos x by 2, or it's going to be a 1 over 3, which is equals to cos of x by 2 here. Now, so here I can see it's a 1 by 3, which equals cos of x by 2. The given domain was for 0 degrees lesser or equal to x lesser or equal to 2 pi. So for this respective x by 2, if I adjust the domain, I shall be dividing every value here by 2, and I can see that this then will become 0 degrees lesser or equal to x by 2, which shall be lesser or equal to pi. Meaning here I should be considering the first quadrant and the second quadrant, but then I also have to consider the fact that it's the cosine, which is a positive. Therefore, it should be the angle which is in the first quadrant, and the basic angle lies here. So let's get cos inverse 1 by 3. So cos inverse 1 by 3 is equal to x by 2, or cos inverse 1 by 3 shall be equal to 1.231, which equals x by 2, and therefore this angle here, it's a 1.231 radian, and then multiplying it by 2, I will be getting x 1.231 times 2, and this answer then shall be equal to 2.46 radian. So it's going to be 2.46 radian. That is going to be the answer of this question. Now the second part of the question says, sketch the graph of y equals fx. So 2 minus 3 cos of x. We have to part 2, it says sketch the graph. Sketch the graph of y equals fx. And we know that for f of x, it is equal to 2 minus 3 cos of x, and this is for 0 degrees lesser or equal to x, which is lesser or equal to 2 pi. Now to sketch the graph again, we have to look into some of the transformations, and what we can see here is that I have a 2 minus 3 cos of x. So again, this means this is going to be the mid-axis, and also it's the translation, it's the vertical translation with 0 and 2. Then here I am having a negative 3. So with this negative 3, if I write them down, there are two things that need to be considered. The negative sign here, the negative sign here, this is actually the reflection in the x-axis. It's actually the reflection in the x-axis. And the 3 here is the stretch parallel to the y-axis. And the factor is going to be 3. So this is the detail that we know about each and every transformation that is taking place here. Now let's get the maximum and the minimum value also. So the maximum value for the graph is going to be the mid-axis value, and then plus the stretch, which is a 3, that gives us a 5, and the minimum value here is going to be the mid-axis value and a minus 3, which gives me a negative 1, meaning the range of the graph is going to be negative 1 lesser or equal to f of x, which is lesser or equal to 5 here. So we have the range of the graph, and again, to sketch the graph, this range is going to be very, very useful. So with respect to the range that I have sketched the axes values 0, pi by 2, pi, 3 pi by 2, and 2 pi. And also I have my y values, the function values on the graph. So starting from negative 1, it should go up to 5. So this is what I have on the function axis here. So again, we have the function which is equal to f of x, which is equals to 2 minus 3 cos of x, and we have already decided that this 2 is going to be the mid-axis. Therefore, at 2, I will be making the dotted line representing the mid-axis here. So we have the mid-axis value. The amplitude needs to be a 3. So here I can see from 2, it's a 3 unit up till 5. And from 2, it's going to be a 3 unit up till negative 1. So I have the amplitude also on the graph. Now the next thing which is left is just to sketch the function values on this graph here. So here, with this negative sign that I have, with the trigonometric function, just remember that if y equals cos of x is a quadratic curve with a minimum turning point, then y equals negative cos of x has to be the reflection, so that now it's the maximum curve, it's the curve with the maximum turning point, meaning each and every point here gets reflected. If this was my x-axis, then I can see that each and every point has been reflected in the x-axis, and now because of the negative, I should be having a maximum turning point. So the same thing is going to happen here. So x is 0. Let's start with x as 0. So if our x here, if I have x is equals to 0 or x equals to pi, because both of them, they are represented on the same x-axis, positive x-axis, I know that cos of 0 is equal to 1 and cos of 2 pi is also equal to a 1. So in the function 2 minus 3 cos of x, if I substitute cos of 0 or cos of 2 pi, then what I see here is that this value then shall be equal to 2 minus 3 cos of 0, 1, cos of 2 pi also a 1. So it's going to be 2 minus 3 and my final answer is going to be a negative 1. So I can plot this point here as a negative 1. Cos of 0, it's a negative 1. 2 pi is also a negative 1 here. In the same manner, if I go for x equals a pi by 2, and also if my x equals a 3 pi by 2, then for both of them, cos of pi by 2 or cos of 3 pi by 2, both of them represent a 0. So if they are representing a 0, then it means that the function value here, 2 minus 3 cos of x, that shall be equal to 2 minus 3 into 0, and I will only be left with a 2 here. So add pi by 2 and add 3 pi by 2, it's going to be the mid-axis value. Then with respect to x as pi, we know that cos of pi equals a negative 1. So f of x then shall be equal to 2 minus 3 times cos of pi, which is a negative 1. And here I can see that this value here becomes a pi, meaning f of pi shall be equal to a 5. Therefore, when x is a pi, the function value here shall be equal to a 5. And then I can see that if I sketch the curve, I will be having the curve with a maximum turning point, which shall be the reflection in the x-axis. It's just that because of the negative sign with the trigonometric function, you just need to flip the curve on the x-axis, so that now initially if cos of x was having a minimum turning point, now it shall be having a maximum turning point. So this is how this question needs to be done. The next question that we have is from summer 2015 and paper 1 variant 1, and it's question number 8 in the paper. And it says that the function f of x equals 5 plus 3 cos of 1 by 2x, and it is defined for 0 degrees lesser or equal to x lesser or equal to 2 pi. Part 1 says solve the equation f of x equals 7, giving your answer correct to 2 decimal places. So f of x equals 7, part 1, solving part 1, it's f of x which equals 7, meaning I should be equating 5 plus 3 cos of x by 2 to 7 here. So to solve the equation, I have been given the domain which is 0 degrees lesser or equal to x lesser or equal to 2 pi. But here I can see that cosine is represented by x by 2. So if it is represented by x by 2, then I should be dividing the whole domain by 2, for which I should be having 0 degrees lesser or equal to x by 2, which is lesser or equal to pi. So x by 2 will be in the domain of 0 to pi then. So let's start solving the equation. I should say it's 3 cos of x by 2, and this then shall be equal to 7 minus 5, giving us a 2. Or I can say it's cos of x by 2, which shall be equal to a 2 by 3. Or further, locate the quadrant, it's a positive cosine, and I will be considering the angles from 0 to pi. Therefore, here I should say that my angle value should be in the first quadrant only, as my cosine is positive in the first quadrant and negative in the second quadrant. Therefore, the second quadrant shall not be considered here. So let's get the cosine inverse of 2 by 3. So the cos inverse 2 by 3, that comes out to be, so the basic angle here is cos inverse 2 by 3, and this value comes out to be equal to 0.84 0.8411 radian, and then I can say it's x by 2, which is equals to 0.8411, or to get the value of x, I can say it's 2 multiplied by 0.8411, and this x then shall be equal to 1.68 radian. So this then is going to be the answer or the solution of this question. So part 2 says sketch the graph of y equals f of x. So again we have to sketch the graph of y equals f of x. So there are again few steps that we need to do before sketching the graph of f of x, which is equals to 5 plus 3 cos of 1 by 2x, and this needs to be sketched from 0 degrees lesser or equal to x lesser or equal to 2 pi. So solving for part 2, sketching the graph, there are few things that we need to understand, the transformation that we need to understand, and then the sketching that we need to understand. So with respect to the function that we have, we should be understanding the transformations that are taking place here. So number one, we have a 5, a constant 5, which means it needs to be translated upwards in the vertical direction, and the vertical translation then shall be represented as 0 and 5. This 3, that is the stretch parallel to the y-axis, and we know that the factor here has to be a 3. 1 by 2x, meaning this 1 by 2 is the stretch parallel to the x-axis, and the stretch factor, we always say when the stretch is parallel to the x-axis, then the factor needs to be a 1 divided by b, 1 divided by this value, therefore it's 1 divided by 1 by 2, and the factor then becomes a 2 here. And also, as we are doing trigonometric functions, and we know for cosine of x, so to get the period of this function, we know that the cosine function, for the cosine function, one cycle is completed in 360 degrees or 2 pi. Therefore, to get the period of this function, which is 5 plus 3 cos x by 2, I should be dividing this 2 pi by 1 by 2. So if I divide this 2 pi by 1 by 2, then my answer is going to be 2 pi into 2, which is equals to 4 pi. Now this means that one cycle for this given function gets completed in 4 pi, meaning 720 degrees. So if one cycle gets completed in 720 degrees or 4 pi, then again check the given domain. And with respect to the given domain, what I see here is that it is from 0 lesser or equal to x, which is lesser or equal to 2 pi, meaning from 0 to 2 pi, 0 lesser or equal to x lesser or equal to 2 pi, just half a cycle shall be drawn here. And then the next step is to get the interval. So to get the interval, what we know is that one cosine cycle gets completed in 4 quadrants. One cosine cycle, it gets completed in 4 quadrants. So this means that for this cycle that we have, if it is taking a 4 pi, then it should get divided by 4, 4 representing the 4 quadrants, and then this interval needs to be a pi, meaning one whole cycle, if I just roughly sketch the x-axis, then one whole cycle shall be for 0, then pi, pi plus pi giving you a 2 pi, and then 2 pi plus pi giving us a 3 pi, and 3 pi plus pi giving us a 4 pi, meaning this is how the whole cycle shall get completed. So, but because again we are restricted from 0 to 2 pi, I should not be going for 3 pi and 4 pi here. So let's start sketching this graph of f of x, which equals 5 plus 3 cos of 1 by 2x. So again, what is the mid-axis? The mid-axis is 5, maximum or the minimum value. So maximum value here is going to be the mid-axis value plus the amplitude, which is a 3 in this case. This is my amplitude, and this is my mid-axis value, which is 5. So it's going to be 5 plus 3 giving us an 8, and the minimum value here shall give us 5 minus 3, which gives us a 2. So to sketch this graph, so I have the maximum value on the graph, which is an 8, and the minimum value, which is a 2. And we know that our graph needs to be between 2 and 8 here. Therefore, the range of the graph, I also have the range of the graph, which is 2 lesser or equal to f of x, which is lesser or equal to 8 here. So if I start sketching for the x value when it is a 0, so x, when x is a 0, we know cos of 0 equals a 1. Therefore, it's going to be f of x, which f of 0, let's call it f of 0, or f of 0 then shall be equal to 5 plus 3 cos of 0, and this then shall be equal to 5 plus 3, giving us an 8 here. And then for x equals pi, our cos of pi, so if I substitute x as pi, I will be getting f of x, which then shall be equal to 5 plus 3 cos of 1 by 2 pi. This becomes cos of pi by 2. Cos of pi by 2 we know is a 0. Therefore, f of pi here shall be equal to a 5 plus 0, which then shall be equal to 5. And then for x equals 2 pi, if I substitute this in this function, then f of 2 pi here shall be equal to 5 plus 3 cos of 5 plus 3 cos of 2 pi by 2. This will give me 5 plus 3 cos of pi. Cos of pi is a negative 1, therefore I should be having 5 plus 3 times negative 1, and it's 5 minus 3, giving me a 2 pi, giving me just a 2 value. So these are the values that we have. Cos of 0 was giving us an 8, so we have an 8 here. Cos of pi was giving us a 5, it's the mid-axis value, and then cos of 2 pi is giving us the minimum value, which shall be the turning point, and here I should be having the curve which is going this way. So this is then going to be half of the cycle of the cosine function for 5 plus 3 cos of x by 2 here. So this is how we shall be sketching the graph for this function. Why f has an inverse? So function inverse is only possible if the function is one to one, or if the function has discrete values or unique values. So we can see here that all the values on this curve, they are one to one. All the values on this curve, they are one to one, and therefore the function f has an inverse, because we have seen here that f of x has, the function has 1 to 1 or 1 to 1 values. And the last part of the question, it says obtain an expression for f inverse x. We have to get our f inverse x. So we know that our f of x was equal to 5 plus 3 cos of 1 by 2x. So it's y, which is equals to 5 plus 3 cos of 1 by 2x, or I can say it's a y minus 5, which is equals to 3 cos of 1 by 2x, and further I can say it's y minus 5 divided by 3, which is equals to cos of 1 by 2x, and then I can say I have to make x the subject, so it's cos inverse y minus 5 divided by 3, which shall be equal to x by 2. So 2 gets multiplied, and I will be having 2 cos inverse y minus 5 divided by 3, which is equals to x. Or switching x and y values, I should say that f inverse x shall be equal to 2 cos inverse x minus 5 divided by 3. So this is how the question needs to be done. And if the question would have asked for the domain and the range of the function, then simply what I should be knowing is I should be flipping the values that are given in the question. So to flip the values, we already have the range of the function, and the range of the function was 2 lesser or equal to f of x lesser or equal to 8. So I would say it's the domain, which is 2 lesser or equal to x, which is lesser or equal to 8. And for the range, I should be writing the value as 0 lesser or equal to f inverse x, which is lesser or equal to 2 pi. I have just flipped the domain and range for the given function to get the domain and range of the inverse function. So this is how we can relate trigonometry to functions also. The next question is taken from October-November 2018, and it's paper 1 variant 2 question number 4. And the question says function f and g are defined by f of x, which equals 2 minus 3 cos of x for 0 lesser or equal to x lesser or equal to 2 pi, and the function g is defined for x by 2 for 0 lesser or equal to x lesser or equal to 2 pi. Part 1. Solve the equation f of gx equals 1. So here we can see that trigonometric functions, they are getting related with composite function fg, which is equals to 1. So we know that for composite function fg, which is equals to 1, we know that in the function f, in place of x, I shall be substituting the function g. Therefore, if my function f is 2 minus 3 cos of x, then in place of x I shall be substituting x by 2, and then this will be equal to 1. So if this equals to 1, I need to solve the equation. The given domain was for 0 lesser or equal to x, which was lesser or equal to 2 pi. So now I can say that this domain shall be adjusted for 0 lesser or equal to x by 2, which shall be lesser or equal to a pi. 2 pi divided by 2, that would just give us a pi here. So if I solve the equation, then I know that this is going to be 2 minus 1, which is equals to 3 cos of x by 2. And further, I can say that this is a 1 by 3, which is equals to cos of x by 2 here. So if this is cos of x by 2, then the next step is to locate the quadrant. My domain now is from 0 to pi, and with respect to this 0 to pi, I should be considering only the first and the second quadrant. But again, the cosine is a positive, therefore I will go only for the first quadrant, and I should be getting the basic angle here. So it should be the basic angle for cos inverse 1 by 3, and the basic angle for cos inverse 1 by 3 in radian. So the basic angle here is going to be a 1.23 radian. So if this is a 1.23 radian, so I should say that the general angle is going to be x by 2, which is equals to 1.23 radian, or my x value here is going to be a 2 times 1.23, and further I can say that this value here is going to be a 2.46 radian. So this is then going to be the answer to this question here. Part 2, we need to sketch f of x, which is equals to 2 minus 3 cos of x, and this needs to be done for 0 lesser or equal to x, which is lesser or equal to 2 pi. So if this is the question, then again I should be looking into the transformations that are taking place. Number 1, we have a vertical translation of 2. Number 2, it's a stretch parallel to the y-axis with the factor 3, and the cosine is negative, meaning it's going to be the reflection also in the x-axis, meaning here it's very much clear that the cosine curve shall be having a maximum turning point. This is how the curve shall be for this function here. So how to sketch the curve? We have the mid-axis value. The mid-axis value is a 2. We have the amplitude. The amplitude here, meaning the height from the mid-axis, this is going to be a 3. Therefore, the maximum value on the graph, the maximum value is going to be the mid-axis plus 3, which is going to be a 5. And the minimum value here is going to be mid-axis value 2 minus 3, which shall give me a negative 1 here. So if I just quickly sketch the graph for 0 to 2 pi, so if I need to sketch the curve, then I know the mid-axis, which is a 2, and I know the amplitude 3, the maximum value is a 5, the minimum value is going to be a negative 1. So quickly, if I just sketch the graph, and to save time, again, I'm repeating, students should be knowing all the axes values here, because now in this question, I will be doing the work directly without doing all the working, just assuming that students know all the axes values for cosine x. So cos of 0 is a 1. So that means in place of cos of 0, if I substitute a 1, this becomes 2 minus 3 times 1. 2 minus 3 into 1, that gives me a 2 minus 3, and my answer here is going to be a negative 1. So I'm just going to write the coordinates here. It's just a 3-mark question, and we need to sketch the graph and we need to save the time. Therefore, I'm just writing the values over here, which is a negative 1. Then we have cos of pi by 2. So if I substitute x with a pi by 2, then cos of pi by 2 is a 0. That means this whole term gets eliminated, then I'll be only left with a 2, meaning here I can say that cos of pi by 2 shall be equal to a 2 here. Substituting cos of pi in place of x, cos of pi is a negative 1, 2 negative 3 into negative 1. Negative 3 into negative 1 gives me a positive 3, 2 plus 3 then shall give me a 5, meaning over here this value shall be equal to a 5. 3 pi by 2. Substituting cos with 3 pi by 2, cos 3 pi by 2, cos 3 pi by 2 is a 0. This whole term gets eliminated, and then again I will be left with a 2 here. And then cos of 0 and cos of 2 pi, they are equal, or even if you substitute cos of 2 pi here, then cos of 2 pi is equal to a 1, and 2 minus 3 into 1, that gives you a minus 1. Therefore, we have already sketched a minus 1 here. So this is how simply a trigonometric graph for the cosine function can be sketched here. Now the last thing is to join the points with as a curve. Therefore, I shall be having here this curve for y equals, this is going to be the curve for y equals 2 minus 3 cos of x. So this is how the cosine functions are sketched and drawn, and it's all explained in detail. So I hope you enjoyed the video and learned from it, and we shall be doing the trigonometric graphs in the next video. So meet you there in the next video. Best wishes for all. Thank you for watching.